Hello, everyone. Welcome to the web seminar, Managing the Edge, Controls and Best Practices for Optimizing Data Center Management, produced by Data Center Knowledge and sponsored by Raritan, Packet, and Myriad. Please note that this web seminar will be available on demand for 12 months starting tomorrow. You will receive an email when the session is available for review. Also, if you have any questions for our speakers, please feel free to type them into the question box on your webcast console. At this time, I would like to introduce our speakers. Bill Clayman is an enthusiastic technologist with experience in data center design, management, and deployment. His architecture work includes large virtualization and cloud deployment, as well as business network design and implementation. As Chief Technology Officer at MTM Technologies, he interacts with enterprise organizations and helps align IT strategies with direct business goals. He also publishes freelance white papers, articles, podcasts, and blogs around data center cloud security and infrastructure management topics. Adam Rothschild is Packet's Senior Vice President of Network and Data Center Infrastructure. He is responsible for all facets of the company's next-generation infrastructure strategy and engineering. Adam was previously a member of Voxel.net's founding technical team, where he served as Vice President of Network Architecture. Following Voxel's sales to Internet in 2011, he held several leadership positions in Internet and was most recently Senior Manager of Network Architecture and Product Development. He studied computer engineering at the University of Maryland in College Park. And with that, I will hand things over to Bill Clayman.
Thank you so much, Ashley, and it's a pleasure to have everybody on the call here. We've got a really great topic. I mean, I'm usually an energized speaker here, but we're getting a chance to talk about something really cool, and that's the edge. Before I go on to a very special next slide, you guys are going to take a couple more seconds here to look at our picture. I kind of want to level set a little bit and talk about what we're going to be discussing here. Throughout our experience, both between Adam and myself, we're seeing that businesses are seeing some big benefits by delivering data closer to the user. And obviously, we're seeing more data being created and it becoming much more important for the user. So as a result, we're seeing that the modern data center has become a lot more distributed. We're seeing hybrid landscapes of traditional data centers with remote data center locations and co-locations. We're seeing new sort of emerging digital trends and outposts that are not just creating new solutions, but they're also creating new challenges, things like data utilization, creating levels of resiliency, and especially working with new requirements around, let's be honest, this is important, uptime and management. So how do you effectively overcome this stuff with, while sustaining things like capacity and operational efficiency? How do you ultimately work with what you and I call distributed computing, or most of all, what we define as the edge? Now, before we get into the conversation, I love an interactive crew and audience. So first of all, by all means, if you have any questions at all, comments, this is a great chance and opportunity for everybody on this call to ask a question, pop something into the Q&A, and then Adam and I are going to get a chance to talk about it at the very end. I mean, whatever it is, small data center or branch location, make sure to get the chance to ask us about it. But before we go on, everyone's heard this word edge, right? Edge computing, edge data centers, but what does it actually mean, right? What does it actually mean to you, our audience? So before we go on, we're going to do three things. So everybody on this call, everybody, all right, put your phones down. You can take a sip of coffee, but take a look at this screen right now. How do you guys define the edge? Is it maybe a data center that's serving more than 50% of broadband eyeballs locally and handling maybe 75% of local internet usage? Maybe you think it's a small data center that's 100 to maybe 10 to 100 kilowatt in IT load, that's geographically distributed, it's close to the end users. You're trying to decrease things like network congestion by keeping mission critical applications running effectively. Maybe it's not about a specific device. Maybe it's about delivering data and specific kinds of resources to people and things. So, in that kind of perspective, what are you effectively trying to do, and what are you trying to create? So I want everybody to click on one of those radio buttons right now. I'm going to give you a couple more seconds here to let us know, how do you define the edge? And then after you let us know, we're going to take a look at some of these results. We're going to get a chance to hear from Adam, myself, and then we're going to go right into the conversation. So doing something a little bit unique here, allowing you guys to define what the edge means to you. And hopefully everybody on the call now has had a chance to take a look at this first screen, answer the question. So let's look at the results. Let's see how you guys are defining what the edge actually looks like. Let's look at the poll results. Oh man, that is so cool to see. So edge IT is not just about specific devices, sensors, vehicles, or machines, or specific location. It's about delivering data and resources to people and things. I love that. Everybody I think on here is getting to the same point and definitely the same perspective. Only 6% really said, you know what, yeah, it's about internet, yeah, it's about, bringing broadband eyeballs locally, but everybody else, more than 80% of you, almost 90, actually more than 90% of you guys are saying that it's a small data center that's close to my users, that's acting as a mission critical piece of my environment, that's acting as an aggregate content and caching point, and again, not just about a specific device, but rather impacting people, process, things, and technology, bringing these powerful types of ecosystems close to the end user. So I know what, I agree with you. Everybody on this call, I think you guys are getting the idea here as far as what the edge actually means to you. So before we go on, Adam, I want to bring you in here for just a little bit before we get into more of the conversation. I'm curious, how do you define the edge?
Well, firstly, thank you very much, Bill, and thank you to all our sponsors. This is a really fun and energizing topic to discuss. And yeah, basically, I'm in fundamental agreement with you and the audience. I mean, I think just the key takeaway here is edge means a lot of things to a lot of different consumers. It's really hard to put in a box or have any specific parameters tied into. But yeah, at a very high level, I mean, we're just working to bring infrastructure closer to the end user and enable a new generation of highly performant use cases that are built around that. And I mean, being an operator here at Packet, I must be party to minimally one meeting a day, either in person or on the phone with a different vendor or partner or prospect of ours, just with varying discussions around the edge. And fundamentally, I don't think you can find any two organizations that have exactly the same definition, but at the same time, I think we all are very much in unity on kind of the higher level goals that we're looking to accomplish through the edge.
That makes sense. Adam, that absolutely makes sense. And, I absolutely agree with your first point there. Any deployment that's not in a major interconnection market site, that's not a large data center footprint. And Adam, we'll bring you back here in just a little bit to talk more about the edge in just a few minutes. But let me give the audience my perspective of what we're seeing in the edge. So, my experience lets me work with cloud, different kinds of IT systems, regardless of age or size of the industry. And what's fascinating is that, the edge that we're seeing is actually multifaceted, not just one technology, like you guys were saying, but rather bringing solutions closer to people around, ecosystem components that they actually require. I mean, listen, you've got things like regional edges, where, the regional co-location data centers for things like content delivery networks. So remember we talked about bringing data closer to the user. Then we've got the industrial revolution. Please understand that the industrial edge is a big part of the transformation process. We're seeing, more things like industrial IoT, machines that used to be analog now have a digital life by placing sensors on them. So there's this industrial edge that's producing data now. Then we've got the local edge. So smaller IT server rooms, closets, these smaller environments that help increase IoT devices, local consumption. And then you've got these wireless telco edges as well that are smaller co-location sites. They reduce latency. They lower backhaul costs. They are capable of supporting, new types of solutions out there. So Bill's definition of the edge and Adam's definition of the edge, we certainly coincide and agree here, but the reality is however you're defining the edge, it's really relevant to your own business. And here's the reality to understand. The business model continues to change, and we're truly at an inflection point where new sorts of digital solutions are not just names or projects. They're becoming realities of what we're working with. And all of this is really fueled by these changing business models that we have to experience. So public, private, hybrid cloud, this explosion of users, the Internet of Things, certainly cloud and SaaS applications. This is changing the way we used to deploy data centers, these monolithic one sites, which, listen, they still have use cases today. But with a mobile workforce, distributed IT, more devices connecting, the edge has become even more important. And not just for distributing data, but for user experience as well. And that's really important to understand. And this level of evolution, it's not going to slow down. We're seeing that things like cloud and data center are experiencing a $1 trillion shift because, again, spending in IT is going to be directly or indirectly affected by this whole cloud conversation. And not just cloud in the sense of, you know, Amazon or AWS. That's not the point here. It's literally distributing your data off of your on-prem location. And then the other thing that we're seeing is that the data center itself has become the heart of any organization, and spending is expanding in that data center ecosystem. Again, we're spending more on end-user hardware and technology to help optimize the delivery of core data center and edge components. And here's the other thing. Private and hybrid cloud are enabling unparalleled capabilities for the business as well as the user, with more than half of enterprises are going to be having some kind of a hybrid cloud deployment by the end of this year alone. We've got like less than a month, or actually just a month and a half left of this year already, and we're seeing companies absolutely adopt this. So, you know, and I argue this all the time. One of the dominant models around today's IT ecosystem is not a monolithic cloud ecosystem or even one data center. It is distributed IT that is capable of supporting more users, more connections, and most of all, a very much emerging digital marketplace that allows you to be much more competitive. Now, here's the other really cool part. There was a super cool study done by Jones Lang LaSalle that actually said that data center deployments continue to increase at a staggering pace. New initiatives are pushing demand for data center space through the roof in many, many markets. And here's the thing. It's not just primary. It's in secondary markets alike. So locations that are remote, locations that might not necessarily be in a major, you know, insert your favorite sports team name here, city, right? We're seeing this level of distribution happen because, simply put, various types of industries are requiring this level of distributed IT. Healthcare, pharma, FinServ, manufacturing, small and medium-sized organizations are trying to impact more of their market, and they can't do this from one centralized location, so the edge becomes a lot more important. And it's really important to understand how much we are actually evolving. By 2021, new data center build-outs are going to be done by service providers. Again, being able to service more of those remote and edge capabilities. We're going to see things like compliance cloud. We're going to see more around security. Here is a really big trend that I want everyone to understand. 43% of IoT data is going to be processed at the edge by 2019, right? I mean, that's crazy. And if I take a look at everybody's in our panel today, or all of our attendees, I bet every single one of you have one or two, probably even three devices in front of you right now that can connect to the cloud, that's processing data, that you might be using for work, for example. But again, these are IoT components, and the only way you can optimize the delivery of the services and what users are actually accessing is by bringing that data closer to the user. So remember, we are spreading out. We are absolutely creating more data, and we are absolutely leveraging this information effectively to do more great things with technology and the things that we have at hand. Now, that being said, there's other things that are increasing as well. We're not just seeing an increase of devices. We're not only just seeing an increase of data. We're also seeing an increase of demand around those distributed IT components and the edge, primarily bandwidth. Edge is increasing bandwidth demands, where corporate WAN traffic is scheduled to grow 15% per year through 2018. So this could be everything from digital signage to web applications, rich content, remote SDCs, and, you know, obviously cat videos, because everyone's got to get their cat video every single day. But listen, that's the reality, is that we are seeing the amount of wide area network and bandwidth requirements increase not just at those primary sites, but at those edge computing sites as well. And in fact, these are big parameters around what specifically we're seeing when this increase of data is happening. Guys, this isn't going to stop. Your edge environments are going to continue to be important parts of your business. You're going to continue to see growth around it, and it's your job to basically optimize this kind of systems to reduce the amount of problems and to optimize what you're delivering to your end users. But here's the reality. It's not always easy. And in my experience and working with all these different kinds of users and environments, I've come up to three kind of headache roadblocks that I've experienced and this is what they are. First of all, changing business models. As your organization grows and as you become, more of a digital and cloud native, you're going to experience changing business models. Users are going to be connecting differently. Customers are going to be requesting services in a different kind of way, and you have to be able to shift and adjust. And one great way to do this is obviously bring your information and data closer to the users, but also make your environment much more susceptible to being agile and ready for this level of digital change and evolution. We're seeing an evolving risk landscape. Now, I want to pause here for just a second. This isn't just about somebody hacking into your environment and stealing data. I'm talking about resiliency, redundancy, and uptime. Your edge IT ecosystem is not just a small data center or a small closet. As a matter of fact, it's a very important part of your business. So what happens if it goes down? What happens if one of your critical sites that is the edge that's producing or delivering content no longer works? What does that do to your users? What about their experience? What about your capability to do business? These are not just small sites where you can set it, forget it, and not worry about it. These are very much important parts of your business, and that is a part of this evolving risk landscape where you have to understand how important those environments are to you and how well you're managing them today. And that brings up to the third point, complexity and fragmentation. The rapid distribution of IT, the development of the edge, it's actually caused a lot of companies to take a step back and say, whoa, I've got 15 different management consoles, 3 different carriers I have to call, 18 different edge data centers I have to worry about, and they're not connected. I don't have a good way to see visibility into it. I effectively don't have a good management framework. I mean, how are you supposed to manage what you can't see? And so a lot of times we experience these growing pains, when we continue to grow and evolve, and especially when we're working with edge computing. So this is a serious challenge where as you grow, as you distribute your IT environment, you do not want to make it complex and certainly fragmented. Now, I'm not talking about a silver bullet here. Please don't mistake that, for having one solution that solves everything, but certainly something that's less complex, that's capable of integrating with virtualization systems, for example, cloud, and unifies your entire environment. Now, from that perspective, it's a fine balance between working with edge data centers and facing the challenges. And one of those challenges that I'm seeing is this balancing act that we have to play between data center availability and business efficiency. In one way, you have to balance the demands of availability and efficiency throughout your edge and the entire data center lifecycle. But where does that scale tip, right? On one hand, you need to worry about uptime and service levels, risk management. That's really important in my opinion. IT productivity, and then on the business efficiency side, carbon impact, energy costs, operational costs, capital costs. I mean, you're going to your CFO and saying, I need to deploy an edge data center. They're going to say, how much does it cost? Well, here's a big response to you. It's about value. It's about understanding how this impacts the user and actually helps the organization make a lot of money. And here's the reality. In the past, when we would distribute this stuff, we had a very legacy way of approaching it. And for years and years, it was the same rhetoric of how we would bridge this management gap. You have IT, you have facilities, and then you have the data center manager. And okay, it worked. It worked for a while, right, where the IT manager or a data center manager could work on their own, have a team. But what happens when you have distributed sites? When you have not 1 or 2 or 3 data centers, but something in the teens, and some of them are tiny, not big data centers at all, but branch locations that are edge components to your business, but also very, very critical. So, in that sense, the only way that I've seen successfully bridge this level of gapping is really by using intelligent tools and bridging those tools, bringing those tools in to help bridge those gaps. So things like asset management, provisioning and monitoring, building management, industrial controls and modeling are all brought into this edge and data center management ecosystem and these tools. So it's not just a guy that's managing your platform, but rather an intelligent ecosystem that's helping you connect the edge and your data center together. Because nothing is stationary. In technology and IT, nothing is at all stationary, and it's never going to be stationary. Every single data center that I've ever had a chance to work with is an environment of constant change. And in this environment of constant change, you need to accurately and timely have good information to make better decisions in real time. I mean, just look at this screen for a second. These are all the components and things that can shift and change and be modeled around. Virtualization, infrastructure management, environmental, dynamic power variation, server consolidation, metrics and reporting. What about regulatory requirements? The uncertainty around planning for capacity or density, energy efficiency. I mean, I can read all these off to you. I practically did. But in an environment of constant change, you need to have tools that keep an eye on this stuff for you, because all of these little components are also going to be impacted by your remote and edge IT systems. So just because you have a small data center doesn't mean that it's no longer, bound by some kind of regulatory compliance, or that you don't have to have good infrastructure management within that ecosystem. So a question goes out to everyone. In an environment of constant change, how are you managing your platforms? How are you making it fundamentally easier to see all of these different kinds of tools in a distributed environment? So in my best practice and in my working with different kinds of solutions out there, it's really important to work with edge and data center management tools that are leading tools that help make your life fundamentally easier. So I'm going to break it down into three basic things: physical, functional, process. So your tools must be able to give you the physical level of visibility. So looking at power systems, cooling systems, IT space, security, and also integration. So how well does it integrate with various sites? How well can you do things like maybe a plugin for virtualization? How good is security? Somebody opening a rack door, or even an entire data center space, how well are you actually controlling the physical environment? Functional, monitoring and alarming, automation and control. So you can set things like thresholds and alerting in your environment, even in your edge data centers. Remember, you might be working with a real lights out kind of an environment where you don't have a lot of people in that ecosystem. So setting things like alerts and thresholds is huge to prevent problems before they become major issues. And then doing things like modeling and simulation. This is great for capacity assessments and understanding how much power and cooling you're actually going to require. Designing your edge is a critical part of the process. Please don't just throw gear at the problem. Really understand what your edge looks like, and then manage that environment around things like modeling and simulation. And then finally, software services and integration. You have to work with technologies that can integrate with the soft side of the organization, right? With the software layer, whether it's a virtualization, whether it's maybe another kind of management tool. And again, the integration piece of this is absolutely important. Now we come to process. And arguably, one of the most important parts of this entire edge data center management conversation: asset management. What do you have in your environment in general? And that's really important. And coupling back to security, do you have a 10-year-old switch that no one has patched in several months? What about availability? Do you know how your systems can respond to some kind of an impact from a disaster potentially? Capacity and change management, being able to forecast what you require to allow IT and business leaders to make better decisions around their data center in general. What about crisis management? That's not a small task. Nobody wants to be in the middle of a data center outage. There's been plenty of fun studies out there, Ponymon being one of them, saying that the average outage these days has gone up to, I think, $750,000, where the biggest one in 2016 was north of $2 million. Listen, you don't want to be paying that stuff out. You might as well invest in good systems that can help you control the crises, that can help you ease your risk and make your organization a lot more resilient. Please understand, again, your edge, just because it's smaller and has less stuff in it than your primary core data center, doesn't mean it's any less important. And I really want to instill that point to everybody. And then finally, financial management and integration. Again, you want to be able to know how much your environment is costing you. You want to be able to create good chargeback modeling. And most of all, you want to be able to create a consumption-based model to know how much you're using every month, every day, and how to optimize the delivery of those critical resources. Because if you lose visibility, if you lose control of that environment, it's going to become a cost center. Even the smallest data center that you might have, your edge location, if you lose visibility into it, it's going to have negative impacts into that. So here's some thoughts, and I want to put it all together for you guys right before I introduce Adam here in just a little bit. It's important to understand how to bring this stuff together. So managing the edge and what you'll need. First of all, is the actual edge data center, and more specifically the integration of virtual, physical, and remote technology. So access, visibility, wide area networking, policy control, and simplified management. So you need to be able to have a complete integration of your edge data center environment where you're capable of seeing those core components throughout the vastness of where your stuff is actually distributed. And visibility is a big part of that, and obviously also is simplified management. You don't want to make this stuff complex. You do want to make it a lot easier. But again, the bottom line here is having access and visibility into your environment. Intelligence is another really important one. So agility, resiliency, and bringing in the business. Power, cooling, redundancy is a really big one. So managing the edge does require intelligence. How good is your ecosystem around managing? How good is your platform around seeing power consumption? Again, maybe things like cooling, and how agile can your software platform actually make your entire environment? And then finally, you're going to need efficiency, optimization, being able to create greater levels of multi-tenancy, for example, and most of all, scalability. Your edge data centers help you scale because they allow your users to connect, access data, be a lot more distributed, and most of all, be a lot more mobile. And from that perspective, management monitoring, smart resource controls, and controlling data center space. With edge computing and distributed IT, the last thing you want to do is have a situation of sprawl. Data center sprawl. That becomes costly, that becomes very fragmented and complex, and you're going to lose visibility in that environment. So make sure that when you're delivering your edge compute technologies, you have visibility into it. You're building it around efficiency and obviously optimization to allow it to scale and basically breathe a lot easier. So from that perspective, I want to give you guys some best practices. In terms of, I've had a chance to work with a lot of different kinds of edge computing environments where we've deployed cloud and virtualization solutions within them. And there's also some tripping points that I want to make sure everyone's aware of so that nobody trips up when they're deploying their own ecosystem. So let me give you a couple of points here. First of all, capacity management within the edge is not about square feet. It's not. It's about filling up the bucket that you've already been allocated. So please don't think that, I need to deploy a lot of space or little space. Know what your bucket is and know how to allocate resources into it. That way you'll know exactly what's in your environment and how to actually plan around capacity. Again, it's not just about the size. I mean, kind of a weird thing here to say that, but it's about what you put in there and how you can use it intelligently. Building out edge data centers can occur in modular fashion. It could be blocks of capacity, for example. It can be gradually used. Again, rather than adding exact amounts of capacity. So know that when you're working with building out remote locations, it's about what you need and how you're actually going to gradually use it instead of just plopping down an exact amount. Because here's the reality. Don't just over-forecast. You don't need to over-provision your stuff, which brings me to my next point. Take inventory of what you have and continually adjust these changes that you're making. Don't just deploy what you don't need to avoid what you don't have to, and you can avoid this level of over-provisioning. And this is a challenge that I'm seeing a lot of organizations run into. They understand the edge, right? They know that they need to bring data to the users, and a lot of times you go into the edge data center, and it's like, why do you have 30 or 40% more gear here than you need to? Well, it's just in case. Well, you should be forecasting that and be able to deploy this stuff more on demand and having good intelligence systems that tell you when you need to be deploying this extra level of capacity. Finally, one of my favorite points, audit periodically because gremlins, right? They exist in every kind of data center, big and small. And what happens oftentimes that even with remote edge IT data centers, a lot of times we think, oh, it's small, nothing's going to happen, it's fine, I'll just kind of keep an eye on the environment from a high stance, and really my primary focus is my main data center. That's not true, because if your edge environment goes down, if you experience a hiccup, it's really costly to send somebody over there to try and repair it. A reactive support or putting out fires is not fun for anybody. So make sure you do audit periodically, even if you have a lot of locations and smaller network and IT, small data centers, for example. Know what's in there and audit those kinds of ecosystems to really understand what you're using and how you can deliver it much more effectively. So I'm going to take a pause there, and it's my pleasure to bring in Adam because I'm excited to hear the actual solutions out there, working with Core and the Edge, and the amazing solutions that are changing the way we see the Edge and working with these kinds of solutions. So I'm going to sit back here, be quiet for a little while, and Adam, it's all yours.
Great. Thank you very much, Bill. I think you provided a excellent market overview, and with that in mind, I think it's also you provided a good segue to kind of go behind the curtains, as it were, and talk deployment and challenges and best practice for a little bit. So firstly, just at a very high level, since we're not a household name, I figure it's probably best I start off addressing the question of what is Packet? Well, we are a relatively new company. We're a little bit over 3 years old, so perhaps that could be viewed as an eternity in the edge compute industry. I'm not sure, but in any event, we're basically in the business of automating fundamental infrastructure, that being servers, network, racks, power, so on and so forth. And our most prevalent offering is by way of our public cloud offering, though we also do some work with enterprise organizations and other service providers, basically utilizing our software in their on-premise environments. So given the nature of the beast, I mean, this is a map of our locations that we've deployed into today for our public cloud offering. We have a number more on the horizons, and between this and our work with some of our clients, we have experience deploying into many dozens of disparate data centers all around the globe, and just wanted to speak a little bit to some of the best practices that we've gleaned. So first and foremost, around definitions, what is the edge, what is the core? I mean, as we've seen before, there really is no consensus. Like, this is something which means something slightly different to just about every person I talk to. At the same time, all these opinions are very much accurate and valid. I mean, so rather than provide concrete dictionary definitions per se, just wanted to provide a couple of thoughts here. I mean, when you hear a core data center, what you're hearing is basically something which is deployed in one of, call it several dozen major cities in the continental U.S., the so-called sports ball cities. You can tell I'm a big sports aficionado from that remark, and similarly around the globe in the major airline hubs. And this is a type of deployment whereby you're deploying into a facility where there is a lot of carrier diversity, a rich ecosystem of providers and routes to select from. Additionally, there's usually an established ecosystem around peering and interconnection, basically the practice of exchanging traffic directly from my network to another network, be it a broadband provider, another content provider, another cloud provider, an enterprise, so on and so forth. These are typically data center builds that are relatively large in size, typically in the tens or hundreds of megawatts in a single facility, and sometimes you even have a campus environment whereby you have many buildings, sometimes even over a dozen buildings that are adjacent to each other on the same campus environment and connected with one another by way of a lot of fiber and conduit. And this is a market that all of the so-called hyperscaler public cloud providers show up at. And in addition, I mean, you're dealing with relatively large and known quantities on the vendor side. There are established procedures with whatever data center that you're in around shipping and receiving logistics and labor around rack and stack and getting remote hands technicians to troubleshoot your gear and so on and so forth. And while it's not to downplay and say these so-called core sites are easy to deploy into logistically by any means, but at the same time, it gets a lot more challenging when you stray out from this kind of a model. And with that in mind, it kind of brings me to the next question of what is the edge? And I mean, again, recognizing there is no one main definition. For some, this can mean you're deployed into dozens of non-football or non-interconnection cities, the so-called Tier 2 markets in the United States. For others, it could be a far broader definition, and it can comprise many hundreds or thousands of regional aggregation ports on your network, depending on what type of a network you have. We're talking potentially cell phone tower sites, even individual poles in a neighborhood for a small cell deployment, regen huts in the case of a fiber provider, could be a telco central office, a cable MSO's head end, and for others it can be, and I'm not even exaggerating saying this, millions of sites. Literally the sky's the limit. I mean, you have people who are treating individual enterprise customer locations or residents, or even something as granular as one specific device or appliance, if you will, as an edge site per se. So again, I mean, there really is no singular definition, and we are talking massive amounts of infrastructure in potentially a large number of sites. And with that said, I mean, in line with what I just mentioned, the power footprint of the so-called edge site could comprise hundreds of kilowatts. It could comprise 1 kilowatt. It could comprise a single outlet. Again, there really is no one right definition. And along with that, a lot of these sites, there are limited redundancy around power, connectivity, and hardware deployed. Like in some of these sites, it might be a lack of 2N power. Some of these sites could even have, and I'm not exaggerating saying this, just utility feed, just basically street power with no power backup. Some of these sites might be interconnected back to a larger network topology with just a single fiber link or a single lit Ethernet circuit even. And again, this isn't even problematic for all the use cases. I mean, as far as the challenges go, I mean, obviously workload management and auto scaling is very important. Along with that, just the notion of global server load balancing and mapping users and devices to the correct location is important. Likewise, around being able to fail over if a single site with these potentially limited redundancies should break away. I mean, obviously, we are not getting here are data centers with 2N power. You're not going to see 5 nines or 6 nines of uptime, but fundamentally that could be okay. I mean, these are solved problems, so they require the right staffing and the right partners to solve for them. And one last point I make is, as far as these edge sites, these are markets that have been historically uninteresting for the so-called hyperscalers, given their usual build parameters and economies of scale. But with that said, I think we're going to see a lot of change and a lot more embedding in this area in the months and years ahead. And yeah, some additional challenges at the edge is, like I had mentioned, there are some challenges around shipping and receiving. I mean, a lot of these sites might not be staffed 24/7. They might not even be staffed at all. You might be basically providing your own labor or relying on a contractor for anything regarding shipping and receiving logistics, basic rack and stack, cabling, critical systems, so on and so forth. And in addition, as I mentioned before, there is a limited carrier and backhaul ecosystem. And along with that, this is a very much a developing market from the perspective of interconnection. And along with that, kind of a piece of cautionary advice that I would offer there is, if you don't plan your deployment correctly around ultimately where does your traffic go, there is a magnified potential for something we as operators call hairpinning or tromboning of network traffic, whereby you might have infrastructure deployed in an edge site, but the nearest point of interconnection with cellular networks or a cable network might be many hundreds or even 1,000 miles away from the edge site. So you're basically sending your traffic from the server deployed in the edge site back to a more centralized meeting room kind of location, and then back around again to the users in the edge market. So you basically added one additional round trip compared to just serving your data out of these central locations. So I mean, again, this isn't all doom and gloom, but at the same time, you really need to be careful about where you're putting your equipment and moreover, what problem you're trying to solve for and what providers you can actually reach out of the local facility or local market that you're deployed into. And along with that, I mean, you're dealing with fundamentally a large number of locations, depending on your deployment, potentially an order of magnitude more locations than you're currently deployed into. So as such, the importance of a solid deployment and automation strategy, good orchestration, good tooling, good monitoring. I mean, these are all things that your organization, of course, should have engineered for regardless, but the importance is just magnified along with the number of sites. And then in addition, we are really at the infancy of the edge, and as such, there is a lack of knowledge sharing. There's a lack of consensus around technical best practices. As we've seen, there's a lack of consensus around what the edge even is, and along the same lines, there are really very few standards bodies, there are very few technical conferences devoted to engineering for this kind of environment, but this is changing for the better, and we're going to see more and more of these organizations and alliances propping up over time. And with that in mind, I just wanted to speak a little bit more on the deployment side. So first of all, I wanted to speak to something called out-of-band network, or OOB for short. To quote an esteemed colleague of mine, out-of-band is basically your saving throw when you goof up. And what I mean by that is it's basically a completely parallel infrastructure to your production network. This is not something that crosses streams with your production network or could be taken down by an outage impacting of your production network. And it's basically your management and telemetry. And I have this debate with a number of clients, even a number of people internally constantly, but in line with Bill's point earlier around outages and the impact of outages, it's just important to note that out-of-band is business critical. It is a great help around outage troubleshooting and restoration time, and it's just non-negotiable from my perspective. And it is, I mean, I could share countless anecdotes, but it's the type of thing that basically makes an outage something which you can troubleshoot and resolve in earnest right away instead of being down for potentially hours or days at a time. And along the lines, basically, and we're going to talk to some of these points in greater detail, basically selecting the optimal hardware for your out-of-band deployment is key. Out-of-band means a lot of things for different people. It can mean a device with management Ethernet connections into routers and switches. It can mean a device with good old-fashioned serial console connections into your core infrastructure, like your routers and switches, some servers. More and more, we're seeing that means both fundamentally, and along with that, another often neglected, but at the same time, very important component is IP-KDM, just the ability to basically have the same type of access to a server that you would have when you're physically sitting in front of the server with a crash card with a monitor and keyboard hooked up. So be sure to do your due diligence, look at whatever hardware you're deploying, and make sure it is the right tool for the job. And then along with that is also, and a lot of these things may seem like common sense, but I've just seen them overlooked and neglected far too often. So bears worth noting is monitoring is extremely important. You need to have a very vigorous monitoring tool set. You need to be constantly monitoring your out-of-band infrastructure. Oftentimes people think, oh, it's the out-of-band network. It doesn't deserve the same level of monitoring as my production network. I'm not going to pull it from my monitoring system. That is fundamentally the wrong approach. And if you do that, what will happen without a doubt is it won't be accessible when you need to access it. And yeah, so another consideration also is just around IP addressing. I mean, you need to make sure that when you're deploying your out-of-band infrastructure, it needs to be reachable. Ideally, this is infrastructure that has a static IP address. It's easily reachable. Again, when your production network is down, you need to be porous, but at the same time, not open to any security vulnerability, but at the same time, again, just be engineering for something that an employee can easily access after hours from their home connectivity, from a mobile device even, and something which is integrated into a VPN, at the same time, something which isn't dependent on your corporate VPN or any corporate IT network, which may or may not be accessible during an outage. And with that said, like in terms of how does one manage their out-of-band infrastructure, there are really three fundamental mechanisms for access. Historically, the most prevalent was the public switch telephone network, also known as POTS, and this is something that's just dying more and more over time. It's not something I would, in good faith, recommend for any new out-of-band deployment. This is something logistically complex to set up. I mean, imagine the process of trying to describe to the phone company where your data center is, how to locate your rack, how to locate your equipment, how to locate a punch block, and these are people that you can barely get to service your residents in a timely fashion, and it's every bit as awesome as I'm describing, and in addition, it's just not very reliable. It's just a text-based kind of single user at a time kind of interface, so this is something that's just not really relevant anymore. So, which brings us to two mechanisms. It's fun. Number one, and this is my favorite where it's available, is an Ethernet drop, just basically buying a IP connection, like 100 meg or gig copper connection from an ISP and installing it into your out-of-band infrastructure. This is a stable connection. It's going to be up a lot of the time, and it's just a very easy way to access your infrastructure, but at the same time, again, depending on what your definition of the edge is, a lot of times you might be deploying in places where there isn't a diverse carrier ecosystem. There's only one carrier and only one fiber route present, so getting a plan B for management access simply is not feasible. So in that case, something that's becoming increasingly important for us here is cellular. We're talking basically like a console server or management gateway with an LTE connection. Here in the United States, all the major carriers offer what they call a business plan or machine-to-machine plan with static IP addresses, so these devices are easy to access. And moreover, another benefit there is you're less dependent on on-site labor in remote areas. You can basically configure these and then literally ship them out to the site, have a remote tech plug them in, and you know the IP address, you can log in, you're good to go. So a really good innovation in this area. And along with out-of-band, another key factor in any sort of management strategy is around power. I mean, this is another one of those things which I consider to be non-negotiable, is deploying a remotely manageable and monitored power strip. Basically, I mean, we have a lot of servers with so-called IPMI and DRAC abilities, but at the same time, these are access mechanisms which are not 100% reliable. They tend to fail over time. So having the ability to remotely power cycle your outlets is extremely important. And I'm a little bit pressed for time, so I'm just going to rush through this a little bit, and for that I apologize. But along with that, basically power and environmental monitoring is equally important. And around this, I mean, I'm not going to go into a lot of detail, but just to give you a couple of ideas, is basically you can get some smart power strips, but not necessarily available on everyone, but you can get some power strips that have basically input sensing on a per outlet level. These are devices that will basically show you how much power in watts your server or equipment is consuming on a per outlet level. Very useful for capacity planning, very useful for, quite candidly, keeping your IPMI and server vendors honest in terms of understanding what the loading of their devices is and comparing busy load against idle load, and likewise on outlet sensing. And likewise on input or receptacle sensing. It's the same situation there. It's just to understand how much power your cabinet is doing, and then the important thing here is beyond just basic alerting if you're over 80% as is prescribed by National Electrical Code, but actually pulling and storing the data and being able to graph it and like trend your power usage over time, like show your power usage on a per data center or per rack basis for a given month or year over year. These are all very important metrics to have and very useful operationally. And I mean, basic operations and outage prevention aside, another benefit there is quite candidly just around billing validation. It's like a lot of, I mean, I wouldn't say a lot, like different data centers bill in different models, but especially if you have a metered power arrangement whereby you're basically billed similar to utility on how much power you're consuming, just being able to validate the invoice that you're receiving, making sure you're not being billed too much or too little for the power that you've consumed. This is an important ability. And likewise, on the environmental monitoring, I mean, a lot of times working in the field, what we have are just various problems with vendors around data center environmentals. I mean, I've run into a lot of situations where just around humidity alone, you have an environment that, especially in the winter months, is too dry. It's like below 15% relative humidity, and it honestly is a bit of a risk. Like, equipment can spark. The environment is more susceptible to fire, so that's not a good thing. And conversely, you don't want a data center that's over, call it 60 or 75% humidity, because at the same time, then moisture and condensation becomes a factor. And at the same time, around power, I mean, this is kind of, I mean, not around power, rather around temperature. I mean, likewise, I mean, it is possible to run IT equipment at a greater temperature than is suitable for human comfort. The folks at Microsoft published a lot of, I believe it was Microsoft and Seagate published a lot of good research around optimal temperatures for IT hardware and at what point hard drives begin to fail, and it's actually relatively higher than one would expect. But at the same time, if you have a data center that's chronically into the 90s or higher on inlet, like in your cold aisle, then obviously that's not a tenable situation and you're risking damage to your equipment as well. So just being able to monitor your data center environmentals is something very important. So what we do is we just go for a power distribution unit that has a environmental probe that will connect to the PDU, and at a bare minimum, what I like to do is monitor hot aisle and cold aisle temperatures on a per cabinet basis. And then again, along with what I mentioned before, these are things that you should monitor against. You should also graph them for trending over time. And there are a number of good open source projects out there which you can use for that. And also there are a number of really great commercial products out there. So the big takeaway is there's really a solution available for every budget, and much like out-of-band, having proper power management and monitoring and proper environmental monitoring, whether or not you're the data center operator, these are all points that I view as non-negotiable when deploying into any site. And with that said, I see we have a number of questions piling up, so rather than bore people with my speech any further, just wanted to wrap up real quickly so that we could hopefully get to some of these questions. So in closing, I'd just like to say that we're in for some really exciting times ahead. As with any emerging technology, what we've seen is deploying at the edge represents some unique challenges, both technical and further up the stack, basically what we engineers like to call layer 8 challenges. And at the same time, the fundamental building blocks are very much business as usual, just perhaps at a larger scale than operators have seen before. But yet, all of the challenges that we're discussing are very much solvable with a combination of the right engineering team and the right vendor selection. And above all, what we've seen is that the benefits definitely outweigh the hassles. So suffice it to say, over here at Packet, we're particularly bullish, as is evidenced by our partnerships and service offerings announced. So please don't hesitate to mail us or tweet us if you'd like to join us on our journey here. And with that said, I'd like to thank our sponsors for their support and logistical work around putting this together, and look forward to the dialogue and hopefully some use cases that we've yet to see. And thank you very much for that.
All right, great. Thank you, Adam. It looks like we do already have quite a few questions, so let's go ahead and jump right in. First question, what do you think are the key drivers to moving to the edge?
Yeah, I can speak to this a little bit. We haven't actually announced any specific customers yet, but what my company does see are a lot of specific use cases and industries. It's like we see a lot of interest in context of vehicle navigation and autonomy. We've seen a lot of interest specifically around gaming, like multiplayer online gaming. There are some games where might even like a lot of the gameplay, like the state data, is needing to happen very close to the user's device that's playing the game, and sometimes even graphics and rendering for the game is happening server side, just because it's very computationally intensive. It's like the rendering will happen server side and then get pushed down to the handset. Along the same lines, like really something that we don't see a lot of is just the traditional streaming kind of use case. It's like a major over-the-top video provider who I think has some public slides available basically summed it up very well in saying, for just general purpose music streaming or video streaming, so long as you're 100 milliseconds away from your user, there's really no perceptible benefit to being closer. So that's really not the use case that we're seeing. But again, we are seeing it's just more of the interactivity around these newer emerging applications.
Right, and I agree with you there that there's, first of all, delivering content is a big use case there, right? Trying to get that closer to the user, make sure it's rich. I mean, latency, network jitters, and, bad cat videos, I'm using that example again. That's all going to turn your users over to a different service to your competitors. Another big industry that we're seeing, healthcare, just as an example, right? Remote locations, using things like telemedicine, delivering next generation capabilities around healthcare services. I mean, that's not just a doctor at a remote office. That's, facilitating medical imaging, x-rays, connecting via, we talked about this earlier, increasing bandwidth to centralizing core application sets. So, I mean, there's a lot of really good use cases. Yeah, just stop from there.
Definitely.
All right. Great. Thank you both. We have time for one more question. What equipment or tools do you use for power management?
That is a great question. And yeah, I mean, so my company specifically, we've written a lot of proprietary tools that are built into our platform. But in terms of just open source kind of off-the-shelf tools that people on the webinar can deploy. Like one good example there is an open source project called Observium, which is good at monitoring power loading, environmentals, doing some of the trending and graphing that I mentioned before. And then also there are a number of solutions built on top of Grafana that we've had good luck with. And then beyond that, I mean, I would say also talk to your PDU vendors. Like a lot of PDUs, firstly, like the current crop of PDUs in the market from a number of vendors have gotten a lot better in their UIs. They have a really good embedded interface, which is accessible with the web browser on the device. And then also a lot of the PDU manufacturers also have some more enterprise-focused management and monitoring tools. So that's another good place to look for tooling there.
All right, great, thank you. Well, I'm afraid we are out of time for this session. Thank you again to Adam and Bill for your presentations. Just a reminder, this seminar will be available on demand starting tomorrow, so feel free to come back and review. For more information and additional resources, please visit raritan.com. Thank you for attending and have a great day.